This code is a simple Python script that imports the sys and warnings modules. The purpose of this script is to suppress any warnings that may be generated by the program. The sys module provides access to some variables used or maintained by the interpreter and to functions that interact strongly with the interpreter. In this script, it is used to check if there are any warning options set. The warnings module is used to control the warning messages that are generated by Python. In this script, it is used to suppress any warnings that may be generated by the program. The if statement checks if there are any warning options set. If there are no warning options set, the simply filter function is called with the argument ignore. This sets the warning filter to ignore all warnings. This code is a Python script that imports several modules and sets a random seed for TensorFlow. The TensorFlow module is a popular open-source platform for building and training machine learning models. In this script, it is used to build a neural network for stock price prediction. The NumPy module is a library for the Python programming language, adding support for large, multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. In this script, it is used to perform mathematical operations on arrays. The Matplotlib module is a plotting library for the Python programming language and its numerical mathematics extension NumPy. In this script, it is used to visualize the stock price data. The Seaborn module is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. In this script, it is used to set the default style for the plots. The Pandas module is a fast, powerful, flexible, and easy-to-use open-source data analysis and manipulation tool. In this script, it is used to read and manipulate the stock price data. The Sclearn.preprocessing module is a library for preprocessing data. In this script, it is used to scale the stock price data. The DateTime module supplies classes for working with dates and times. In this script, it is used to manipulate the dates in the stock price data. The TQDM module is a fast, extensible progress bar for Python and CLI. In this script, it is used to display a progress bar during the training of the neural network. Finally, the tf.compact.v1.random.set_random_seed 1234 function sets the random seed for TensorFlow. This ensures that the results of the neural network training are reproducible. This code is a Python script that reads a CSV file containing stock price data for Google, GOOG, for a year. The Pandas module is a fast, powerful, flexible, and easy-to-use open-source data analysis and manipulation tool. In this script, it is used to read and manipulate the stock price data. The read_CSV function is a Pandas function that reads a CSV file into a Pandas data frame. The ./dataset/googear.csv argument specifies the path to the CSV file. The resulting data frame is stored in the variable df. The head function is then called on the data frame to display the first 5 rows of the data. This code is a Python script that performs data preprocessing on the stock price data for Google, GOOG, for a year. The min-max scaler function is a function from the sclern.preprocessing module that scales the data to a specified range. In this script, it is used to scale the closing price data to a range between 0 and 1. The fit function is called on the min-max scaler object with the argument df.illic, 4 to 5. A type float32. This selects the closing price data from the data frame and converts it to a float32 data type. The type function is a pandas function that converts the data type of a pandas object. The resulting min-max scaler object is stored in the variable min-max. The transform function is called on the min-max object with the argument df.illic, 4 to 5. A type float32. This scales the closing price data to a range between 0 and 1. The resulting scaled data is stored in the variable df_log. The pd.dataframe function is then called on df_log to convert it to a pandas data frame. Finally, the head function is called on the data frame to display the first 5 rows of the data. This code is a Python script that splits the stock price data for Google, GOOG, into training and testing sets. The test_size variable is set to 30. This specifies the number of days of data that will be used for testing the model. The simulation_size variable is set to 10. This specifies the number of simulations that will be run. The illic function is a pandas function that selects data from a data frame by index location. In this script, it is used to select the training and testing sets from the data frame. The df_train variable is assigned the result of selecting all rows of the data frame up to the index test_size. This selects all rows of the data frame except for the last test_size rows, which will be used for testing. The df_test variable is assigned the result of selecting the last test_size rows of the data frame. This selects the last test_size rows of the data frame, which will be used for testing. The shape attribute is a pandas attribute that returns the dimensions of a data frame. In this script, it is used to display the dimensions of the original data frame, the training set, and the testing set. This code defines a neural network model for time series forecasting using TensorFlow. The model is based on the gated linear unit, GLU, and the multi-head attention, MHA, mechanisms. The pad_input function is a helper function that pads the input tensor with zeros. It is used to ensure that the output tensor has the same dimensions as the input tensor after convolution. The conv_block function is a helper function that performs a convolution operation on the input tensor. It is used to extract features from the input tensor. The glue function is a helper function that performs gated linear unit activation on the input tensor. It is used to introduce nonlinearity into the model. The layer function is a helper function that performs a single layer of the neural network. It is used to build the neural network by stacking multiple layers. The model class is the main class that defines the neural network model. It takes several hyperparameters as input, including the learning rate, number of layers, size of the input, size of the hidden layer, output size, kernel size, number of attention heads, and dropout rate. The X and Y placeholders are defined for the input and output data, respectively. The encoder_embedded variable is defined as the output of a dense layer applied to the input data. The first for loop iterates over the number of layers specified by the num_layers hyperparameter. In each iteration, a layer is added to the neural network using the layer function. The encoder_block function is used as the block_func argument, which is defined elsewhere in the code. The encoder_output and output_memory variables are defined as the output of the final layer of the encoder. The second for loop iterates over the number of layers specified by the num_layers hyperparameter again. In each iteration, an attention mechanism is added to the neural network using the conv_block function. The attention mechanism is used to weight the input data based on its relevance to the output. The logits variable is defined as the output of a dense layer applied to the final output of the encoder. The cost variable is defined as the mean squared error between the predicted output and the actual output. The optimizer variable is defined as an atom optimizer that minimizes the cost. The calculate_accuracy function is a helper function that calculates the accuracy of the model. The anchor function is a helper function that applies an anchor to the input signal. It is used to smooth the input signal. Overall, this code defines a neural network model for time series forecasting using TensorFlow. It includes several helper functions and hyperparameters that can be adjusted to improve the performance of the model. The model is based on the GLU and MHA mechanisms, which are commonly used in natural language processing and computer vision tasks. This code defines several hyperparameters that are used in the neural network model for time series forecasting in the forecasting stock.type and file. The num_layers variable is set to 1. This specifies the number of layers in the neural network. The size_layer variable is set to 128. This specifies the size of the hidden layer in the neural network. The timestamp variable is set to test_size. This specifies the number of days of data that will be used for testing the model. The epoch variable is set to 300. This specifies the number of epochs, iterations, that the model will be trained for. The dropout_rate variable is set to 0.7. This specifies the dropout rate, which is the fraction of the input units that are randomly dropped out during training. The future_day variable is set to test_size. This specifies the number of days of data that will be predicted by the model. The learning_rate variable is set to 1e-3. This specifies the learning rate, which is the step size at which the optimizer adjusts the weights of the neural network during training. Overall, this code defines several hyperparameters that are used in the neural network model for time series forecasting. These hyperparameters can be adjusted to improve the performance of the model. This code defines a function called forecast that performs time series forecasting using a neural network model. The tf.reset_default_graph function is called to reset the TensorFlow default graph. This is necessary to avoid conflicts with previously defined TensorFlow graphs. The model class is instantiated with the hyperparameters learning_rate, num_layers, df_log.shape1, size_layer, df_log.shape1, and dropout_rate. This creates an instance of the neural network model. The TensorFlow session is created using tf.interactiveSession. The first for loop iterates over the number of epochs specified by the epoch hyperparameter. In each iteration, the training data is split into batches of size timestamp. The x and y placeholders of the neural network model are fed with the input and output data, respectively. The logits, optimizer, and cost variables are computed using the ses.run function. The total_loss and total_ec lists are updated with the loss and accuracy of each batch. The second for loop iterates over the training data in batches of size timestamp. The logits variable is computed using the ses.run function. The output_predict variable is updated with the predicted output. The third for loop iterates over the test data. The O variable is defined as a slice of the output_predict variable. The last element of O is fed to the neural network model to predict the next value. The output_predict variable is updated with the predicted value. The anchor function is called on the predicted output to smooth the signal. Overall, this code defines a function that performs time series forecasting using a neural network model. The model is trained on the training data and used to predict the test data. The anchor function is used to smooth the predicted output. This code performs a simulation of time series forecasting using the forecast function defined in the forecasting stock.type and file. The results list is defined as an empty list. This list will be used to store the results of each simulation. The for loop iterates over the range of simulation_size, which is set to 10. In each iteration, the forecast function is called to perform time series forecasting using a neural network model. The results of the simulation are appended to the results list. The print function is used to display the simulation number. This is useful for tracking the progress of the simulations. Overall, this code performs a simulation of time series forecasting using the forecast function. It performs 10 simulations and stores the results of each simulation in a list. This is a common technique for evaluating the performance of a machine learning model. This code generates a plot that compares the predicted stock price trend to the actual stock price trend for Google, GOOG. The accuracies list is defined as a list comprehension that calculates the accuracy of each simulation using the calculate_accuracy function defined in the forecasting stock.type and file. The df_close illit test_size values argument selects the actual closing price data for the test period. The r argument selects the predicted closing price data for the test period. The plt.figure function is called to create a new figure with a size of 15 by 5 inches. The first for loop iterates over the range of simulation_size, which is set to 10. In each iteration, The predicted closing price data for the test period is plotted using the plt.plot function. The label of the plot is set to forecast %d%no plus 1, where no is the simulation number. The second plt.plot function plots the actual closing price data for the test period. The label of the plot is set to true trend, and the color of the plot is set to black. The plt.legend function is called to display the legend of the plot. The plt.title function is called to set the title of the plot to average accuracy, %.4f%np.mean accuracies, where np.mean accuracies is the average accuracy of the simulations. The plt.show function is called to display the plot. Overall, this code generates a plot that compares the predicted stock price trend to the actual stock price trend for Google, GOOG. The plot includes the predicted closing price data for the test period for each simulation, as well as the actual closing price data for the test period. The average accuracy of the simulations is displayed in the title of the plot.